Another induction question, this time involving complex numbers. I'm going to try and prove the result that a complex number to the power of n, take its conjugate, is equal to the conjugate of the complex number to the power of n, where n is a positive integer. I'm going to prove this by induction, and just a word of warning, I'm going to use this result in the proof. The conjugate of a product of complex numbers is equal to the product of the conjugates. Now, you may or may not have seen this result. This is a result you can prove as a nice little side exercise. So I'll leave you to prove that. I will be using that in a moment in the proof. So let's go. As always, first job is the basis step. I'm going to let n equal 1, and I'm going to look at the left hand side, which is going to be z conjugate, and I'm going to look at the right hand side, which is going to be also z conjugate. Therefore, the result is true for n is 1. Trivial in this case, but I still need to show that I've checked it. Inductive step. As always, begin with my assumption. Assume the result is true for some n equal to k. Write down what that actually means. So I'm actually assuming that z to the k conjugate is equal to z conjugate to the k. I'm assuming that. Now I want to show that the result follows for n equal to k plus 1. And again, just to write down what that actually means, i.e. I'm going to try and show that z to the k plus 1 conjugate is equal to z conjugate to the k plus 1. That's what I'm going to try and show. So how am I going to do it? Okay, well, let's start with one of them. Let's start with the left hand side, which says z to the k plus 1 conjugate. I'm going to write that as z to the k times z conjugate, and this is where I use the result I mentioned at the start. I can take the conjugate of these two complex numbers separately. So this becomes zk conjugate times z conjugate. Now I'm going to use my assumption, because I've assumed that z to the k conjugate is equal to z conjugate to the k. So I can swap this around. So this becomes z conjugate to the k times z conjugate. That was using the assumption. Create a bit of space. And now you can probably see where this result's going to come from. I can see that z conjugate is common here, so I can take z conjugate out. What have I got? I've got what's the power of k plus 1 there, and that equals the right hand side as required. So I've done the hard work. Now all I need to do is finish with my conclusion. Hence, by mathematical induction, the result is true for all n belonging to the set of z integers, z positive integers. A similar question for you to try yourself. Can you prove this result? The sum of n complex numbers, conjugate, is equal to the sum of the conjugates. Now, to prove that, you'll need to use this result for two complex numbers. And again, it's a relatively straightforward exercise to prove this result using z is equal to a plus ib. You can prove that result quite happily and use that then in your proof of the more general result there.